So content of my presentation, I will explain you that there is KNX Data Secure and KNX IP Secure. What is the difference? Why? What problem did we want to solve with KNX Secure? Did we reach our objectives? KNX Secure, is it just a manufacturer, is it just a KNX solution, or is it also standardized? The answer to that is yes. Is it a well-designed security solution? Yes, it is, because it was recently VDE certified. And I think I will not have time for that, but I will also tell you how in an ETIAS 6 you can realize your KNX Secure installation. Okay, we've got two different flavors of KNX Secure. We first wanted to secure the IP communication. So, as you know, KNX has the possibility to transport information across an IP network. First, we wanted to make sure that anybody listening in on an IP network cannot record telegrams and manipulate telegrams. This is the first thing we wanted to secure. Secondly, of course, we also wanted to secure if a twisted pair device is talking to another twisted pair device. For some applications, sometimes you want to protect this communication. You don't want a hacker to be able to interpret this frame. This holds true for a twisted pair device, but this could also hold true for a wireless device. Because the communication is in the open air, this you really need to protect. So this is referred to as KNX Data Secure. Needless to say, these things go hand in hand, and both of this is supported in ETIAS 6. It was already supported in ETIAS 5. It continues to be supported also in ETIAS 6. I already touched upon that. What problem did we want to solve? We wanted to avoid that somebody records telegrams from or communication from the bus and plays it to this same installation after some time, or even manipulates these telegrams. And of course, if these telegrams are correct, then the devices may react. They may open the door or whatever. And also we wanted to make sure that everybody, if somebody has an interface to a KNX installation, this attacker can visually see the telegrams. I already told you that we want to secure communication on IP. We wanted to secure communication between end devices, but we also want to secure the way the ETIAS configures a product. Because also there, the hacker may be listening on. We want to avoid that during configuration already the product is hacked. Of course, we did not start from a clean sheet. It is a bit utopia to think that KNX can still reinvent the wheel. So we took algorithms that are out there to use and to make a concept on how to secure a device or device communication. We used AES 128 CCM to protect communication between devices. These algorithms are, of course, internationally standardized. If you want to really know how this all works, you can find YouTube films, of course, online. We also, to securely give a password to an interface, we also use internationally standardized algorithms like elliptic curve Diffie-Hellman. I already announced it. Of course, KNX has the habit, when we have developed something or we have specified something, we specify it for our manufacturers, but we also bring it to international standardization. So we put the data security standard onto the table of Senelec. We put the IP secure solution onto the table of ISO. So both solutions are internationally standardized as EN 50090-34 and ISO 22510. So also other manufacturers not part of the club can buy this standard and develop. I announced you that VDE looked at our solution to really look at whether we used state-of-the-art mechanisms, and VDE recently confirmed that this is the case for data security as well as IP security. Okay, I've got, I think, I don't know how many, okay, 5 minutes, okay. I will give you some minor details on how things are secured within the tool. So when you make a project and it includes secure devices, of course, if you hand over this project to somebody else, you also want to be sure that only the person to which you hand over the project and you hand over the password can open and view the project. So ETS will require from you that you password protect your project, which includes security. Also, when you connect to a so-called KNX Net IP tunneling interface, so mostly for visualization purposes, you will be required, or you will have the possibility, you're not required, but you will have the possibility to also secure this connection with a password. When you integrate a product into the ETS, if it's a secure product, will allow you to read a QR code which is indicated on the product. You will be able to hold it in front of the camera and it will read out a so-called factory default setup key. This is the key that is used to protect the first communication to a device so that you are able to securely give it yet another key to be used for configuration purposes. So all these security keys are stored in the ETS project, and also the keys that are used to secure the communication between two functions in KNX. When you want to export all these security keys to a third party, then ETS will allow you to make a so-called key ring, so all the keys of the installation, and export that, of course, also in a protected way. You can export then all the keys of your project. I explained this just before. So ETS has the possibility to read via a QR code this configuration security key, so this bootstrap key. So you can also type it in, but of course you want to avoid that. We are also working on a solution where the ETS will fetch this FDSK from a cloud infrastructure instead of having to use the camera for 1,000 devices if you have 1,000 devices in your installation. If you want to export for a dedicated interface the key ring, you can also do that in ETS. So you don't have to export the entire key ring, only the key ring that is needed for an interface. Important in ETS, if you say, okay, my backbone needs to be secured, then ETS will not allow you to assign devices that cannot support security. So ETS confronts you with the question, okay, you said you wanted secure, so please only integrate secure devices or devices that support security. I think I already explained you that. I also wanted to show you this. This demonstrates how in an ETS project where you have the password and you have all the keys, you can visualize the data that is securely communicated between devices. No problem. You see what functions are used and what data is sent to the devices. No problem. If you don't have, with an ETS, without the project secrets, you connect to an installation, ETS will show you things that you cannot interpret. The data is uninterpretable. A very important aspect also, because we also introduced the possibility to extend a line with a so-called security proxy. So you have a wired system and a wireless extension. Now you can integrate a product which is called a security proxy. This will translate secure messages to plain and plain to secure. And because of this introduction of this new product, the former rule was if you connect a function to another function with a group address and you want it to be secure, you could not add a function that is unsecure. Now the rule is if you have a security domain within a security domain that is secured, you can also not add a function that is unsecured. However, beyond this security domain, you can add a plain communication if there is a security proxy in between these two devices. That is now also possible. Okay, this was in a nutshell and very quick KNX Secure.